So this section I'm going over now is DMA 30, Section 4. For this section here, we're actually, if you already completed Section 3 deal with a lot of word problems, word applications. Now we're going to go into shapes, and we're going to get also a little bit into word applications or how it pertains to the real world as far as um, uh, putting two triangles together and find out they're similar. So for the first part of the problem for number one, they kind of wanted you to set them up as a ratio. So understand we have triangle A, 2, there's the division bar, B. So whatever you choose from A, you need to also choose the same side from B. So say for instance, I chose 22. If I chose 22 to put here, well, the same that corresponds to this side will be the 11. So you put that here and then simplify your answer. So again, don't forget to simplify answers. So this is pretty much all that's to this section is when they find if you're making a proportional to solve. So I'll show you in an viewing example. If you choose 5 from the small one, then 15 is the same side from the larger one. So I have 15 over here. So that's why they're actually the same side, different triangles, but same side. And then n corresponds with this one. So once we set it up here, once again, multiply the two numbers that you have and divide by the number left over. So let's move towards one that has multiple steps, which is this one. So this one kind of is really good because it kind of walks you through to make sure you really understand and how you can relate it to the real world. So all these two triangles similar. They are similar because they both have this little box, which means again we're on 90 degree angle, and they both have this 90-degree angle. So yes, they are similar. So we want to figure out the sides that are corresponding to each other or proportion to each other. Make sure you select all that applies. Don't just select one. So if you look here, the height of the building and the height of the pole, those are the ones that's going to correspond because they're both coming from the same side. And then the building's shadow, which is here. So if the sun is up here and is pointing down here, it makes a shadow for this length. So the building shadow and then the flagpole shadow. And the rest of them really don't make sense because they don't correspond to each other. So once we set it up, if you place the building height here, again, if you started off with height with this one, notice for this one here, both in the building and building will go on top and the flagpole measurements go on the bottom. So building height, we do not know, but we do know the building's shadow, which is 44. And then for the flagpole height, which is here, we also need the flagpole shadow, which is going to be 4 for this one. So once we do this problem, multiply the two numbers that you have, divide by the number left over. For this particular one, if we use our calculator, we're going to do 25 times 11, or they simplified it for us, so we don't need to simplify because the calculator is going to do the stuff for us. So 25 times 4 is 44. So we're going to do 25 times 44, and then divide by the number left over, which is 4. So we get 275. So just to interpret what it means that because we found what x is, the building's height is going to be 275 feet tall. And I think that should cover, yes, that should cover everything in this section as far as section 4 when we just actually try to put two shapes together and see if they are similar and how they correspond.